Hello, morning everyone. Um, so please scan the QR code, and um, for today's lecture, I will review a little bit what we did last week, maybe around 5 to 10 minutes review. Then I will going for the preparation for your midterm, okay? Because there is, I think, I need to summarize the whole 4 chapters, what you have learned, the important points on each chapter, and we will have also the examples. I think I've sent the last 2 years exam. Um, I've sent it to you, and if you try to solve it, let me know which questions you need to you want to know which solutions, okay? Which numbers you think it's difficult from last 2 years, okay? And we can discuss today. I will discuss maybe a few numbers, okay? Because I think several points we have also discussed in the class before, okay? So let's start with the last week review a little bit. So one way to approach the integrations is by a geometrical approach that you can imagine. The idea of integration is basically finding the area under the curve of the f of x. Okay, you find the area, and that is your integration. Okay, and we will have some approximations that we call the Riemann sum. This is the idea, the notations. Okay, so sum of the uh, the height, the functions, multiply with the delta, the width is the box area, and you plus all the box area under the curve. And by the definitions of limit, as the number getting larger and larger, going to infinity, we will get eventually the integration from a to b of fx dx. Okay, that's the definitions. We call this definition by Riemann sum. Okay. So in the first part, we will learn the approximations, how we approximate the Riemann. Okay. Okay. So basically, in integrations, the first part is we will go approach this left side. Okay. We will have approximations. Okay. So before, in derivative, you have approximations using the derivative, using the tangent line, right? Now the approximation is using this Riemann. It's called the Riemann sum. Okay? And basically, there are at least uh, the first part is we have two methods, left and right endpoint for the approximation. We have left endpoint in which the box will touch, the left side of the box will touch the functions, and right endpoint where the right side of the box will touch the function. And you will see the difference if this is the same function. Okay. And if you see any boxes having a gap between the function and the box, if there is a gap here, we call this is the underestimate approach. Okay, and this is overestimate, and we can know the error based on the difference between the functions and the box. That is the error. Okay. And also left, right, and the other one is the midpoint. So the difference is how you start the delta. Okay. The delta x, maybe the delta x is maybe similar width, but the point that's starting, this A, maybe will be different. Okay? Maybe different. Okay? So maybe this is maybe 1, this is 1, maybe this is 1.5, okay? Maybe shift to the right. Okay? And also depends on the functions, the underestimate and overestimate. It's not always left endpoint always underestimate, not always the case. Okay, so it also depends on the function. Like these functions can be like this, right? And of course, if you observe with left and right, the box also will be different. Okay, and then we have the midpoint. Instead of left or right, we will use the point at the middle of the box. And this is how you approach half of the previous terms and plus the next terms, the midpoint. And then we have also the trapezoidal. So we change the box, the rectangular box with the trapezoids, and we are using the area of trapezoids. Okay, so there are 4. Okay, left, right, midpoint, and trapezoidal. Okay, and the conclusion actually for definite integral, I haven't said last week, but the conclusion is the definite integral. Okay, if you take a look the definitions, so definite integral meaning the integrations have exact interval a b, and the total solutions will be the exact number, okay, the exact solutions. Okay. So if the functions defined, okay, from a to b, okay, they define, and if we define the interval, becomes with the like a box, okay, and we have the delta b minus a over n, and if we define our x, okay, from a, and then x1, x2, x3, and the distance a to x1 will be the delta, and the last part will be b, and all the x with the asterisk, this is our sample point. Then if the x all their positions is on the interval, then the definite integral is fx dx is the Riemann sum, okay, of the this xi asterisk, the difference from the general terms. This is exactly already have a sample points, meaning this is have an exact solution, exact number, okay. But the two equations is similar, okay? And to provide this equation true, we need to provide that the limit exists, okay? And it gave the same value for all possible choices of sample points. So the sample points works as a proof, okay? Works as a proof for any functions that have its limit value, then this integration will be exist. Okay? And we say, if we have proven this, then we say the function is integrable. Okay. Before in differentiation, we say the function is differentiable. Okay. So it's kind of looking forward and backwards with derivative and integrations. Okay. And for next week, I will continue from here and going for some proving with the fundamental theory in calculus. So fundamental theory of calculus say that what is the relations from the derivative to integrations and how we prove that. And that is actually the essence of the whole calculus lecture, from calculus 1 to calculus 2. Okay, but that will be next week. Okay, so that's the integrations, and I think we can move on now to the midterm. Okay, midterm preparation. So I will. Oh, one more thing. I think this is also a notes for integrations. I believe you have learned the symbol before, this summation symbol with sigma. This is some notes that if you have sigma 1, okay, is equal n, which means you need to plus the symbols as long as n terms. Okay. And if this is having some I symbols here, you can start with I1 until n and then plus. Okay. And you can also have the square, and the right side part is I've already resulting the final results. Okay. Maybe if you have time, we can discuss why this resulting these terms. But actually, that's to prove that that's quite long. But actually, why we are doing this? Okay. Remember in your derivative, because you have derivative definition is using limit, right? And if you don't know, for example, the x squared is 2x, right? The derivative. But if you want to prove x squared is 2x, you need to use the limit. You put in the x plus h minus x over h, right? This is the same thing in integrations. So if you want to integrate with the Riemann, using the sigma, if you see any terms like this, then you need to substitute with all these nodes to get your integrations. Okay, that if we haven't proved anything yet. So this is basically used for integral calculations if we don't have any proof to integrate, or if we don't have any techniques to integrate. Okay, it's like the derivative parts. If we don't have any proof to derive, then the basic terms to calculate derivative is using limit. Change all to, if not fx plus h minus fx over h, you can use f of x minus f of a divided by x minus a. Either two of them are useful terms for basic derivative. Okay, so that's the some notes, but we will use it just for proving only. Okay, so yeah, that's the summations. Okay, now we can move to some summary. Okay, for those of you who just come and previous one also, if you need the QR code, I will give you at the end. Okay. Okay, let me have a simple summary and then go for some examples and maybe some questions from the PDF that I have sent to you, the I think last 2 years midterm. So summary for chapter 1 to chapter 4. Let me start with the functions. Okay. The important in functions at the very beginning is to know first is domain, the possible x, and range, the possible f of x. Okay. And then some functions that have interesting in behavior. For example, the exponent, and logarithm, because you have specific domain for logarithm. And then for exponent, the graph will be having specific behavior also. And for exponent, the derivative is spatial, because if you derive the exponent, it will become the exponent, right? Okay. And then we have the transformations of function, meaning you can transform old functions to new functions. It can be shifted left, right, up, down, okay? Or maybe multiply and become bigger or become smaller. And also the inverse. So basically inverse, the idea is we are switching domain and range, okay? But if we are analyzing the inverse, the idea for inverse, we need to have the functions is one-to-one functions. Need one-to-one functions. And how to check one-to-one functions? Okay, let me give you, first is just like this. Okay. The blue color here, the blue functions here, because if we put any x, it will result in at least one functions. We call this is one-to-one function. Okay. If I have like this, is this one-to-one functions? Okay. The simple way to check one-to-one functions is using the line. Okay. So, for example, let's focus on the left side. So we have line, line, line. Okay. So the green color here always cut the functions exactly at one point, right? But here at the right side, if we cut here, it will have 1, 2, 3, 4 points, right? It's more than one. So we can conclude that this is not one-to-one functions. But the question is, can we make the functions inverse? Okay. Can we find the inverse? We can if we, let me modify the function. So if the functions, we only consider this part. If we consider only this part, then I think it's safe, right? It's only 1.1.1 point, right? So the idea is domain and range is not always like all domain, all range is not always exchangeable, but you can have restrictions. In some domains, in some range, it still can be inverse. So you need to restrict the domain and range. So domain and range restrictions. Okay. I think that's the chapter 1. Chapter 1. So this is chapter 1. Okay. Now, chapter 2 is the limit. Limit, we start from the tangent and average rate of change. Tangent is the instant rate of change. What is the difference? We have like this functions. Okay. The tangent at maybe here at A is this line. Okay. But the average rate of change is from here and to the endpoint here. This is average. This is tangent. Okay. And by the concept of limit, we can go for derivative. But before that, in limit, there are several points. The limit law, I think you should be able to use the limit law. I think there's no complicated things in limit law, and the precise definitions of limit. This is using the epsilon and delta. And if you need to prove, start with fx and epsilon, and simplify and try some delta and check again to prove fx. And then we have continuity. Basically, the idea for continuity is we need to prove this the limit from right and from left. And then actually we have the horizontal asymptote. This is when we are using limit as x approaching infinity of fx. This will be resulting some value, and this will be the asymptote. And we have vertical asymptote. This can be resulting infinity or negative infinity. It can be, or it can be negative or positive. We call this, in your textbook, this called limits at infinity. And this is infinite limits. Limits at infinity is when you approach x to infinity. Infinite limit is the result. The result is infinite or negative infinite. So I modify a little bit for the summary, and you can, if you want to check the textbook, you can check. But I want to modify some sections so you get the idea how to study, how to start the study. Okay, so that's the chapter 2, the limit. And chapter 3, this is basically derivative and some techniques for the differentiations. We start with the definitions. Maybe I will write the definitions. So this is first definitions and second definitions. Both are, if you draw with the graph, both are actually similar. So you can choose one or two for the definitions, both the same. We have the polynomials. Start from like x with the n power. And we also have proven this to be n, x, n minus 1. Okay. And we have product and quotient. So f, g, and f over g. I believe you should be able to differentiate the product rule and quotient rule. And the chain rule. So chain rule divide the x will be f prime, multiply the inside. And then implicit, a simple example, if you have x squared plus y squared, 5, then if you need to derive implicitly, it will be 2y, and then multiply dy dx, 0, and you can solve this. That's the implicit. And also log, like the ln x, dy dx will be the 1 over x. Okay. And the inverse of the trigonometry, for example, the tangent inverse, this will be 1 over. This is just a small example, but you need to be able to, if you need to solve others, then based on this tangent inverse, you need to be able to solve other inverse as well. And also at the exponential growth, remember we have these terms. Okay, the k is constant. K can be positive, k can be negative. If positive, we say it's growth. If negative, it's decay. And in calculus, we focus to look for rate of change of A, in which you derive, and based on derivative of E, then the exponent will resulting another exponent. Okay. And the K will be, the constant K will be going to the front. Okay. Another point is the related rates. So basically, this is find relation between variable and relate them to rate of change. Rate of change, usually we are using the time, ddt. I think that's basically the chapter 3. We have the linear approximation, but I want to move the linear approximation to chapter 4. So you may have idea what is chapter 3 all about. So chapter 1 is functions, chapter 2 limit, chapter 3 is actually differentiations from definitions until several examples how to find the relations between some rate of change of some variables, exponential growth, exponential decay, several techniques to derive. That's basically the chapter 3. And chapter 4, I want to move the linear approximation to chapter 4. So you can get the idea how to explain one by one, okay, from the linear approximation. So basically, you learn the tangent, right? You learn the tangent line. And basically, tangent line is just a linear equation. Start with the very basic line equation. And we can use this line equations to approximate some functions. Okay, so we can use the tangent, the gradient, and we can use for linear approximations. So that's why I want to use the linear approximation as the intro for chapter 4, because chapter 4 is actually application of derivative. Okay. And from linear approximation, we also have the Newton's method. Let me write the linear approximation is fa plus f prime a x minus a. Newton's method basically the same as linear approximations, but the fx is 0. Then we get the x minus a is minus let's say this is let's say this is x0, or maybe to differentiate with the linear approximation, let's make this x0. And then from here, because we start from the linear equations, we have the mean value theorem. So from the same line equations, we can now observe the f prime. In mean value, we need to find the c in between a and b. There is axis, the number c in between interval a and b. If the f prime is equal so this is the tangent or gradient, right? And the right side is the average value, average rate of change. And from mean value theorem, we can go to max mean values. The implication will be the f prime x greater 0, f prime x less than 0, f prime x equals 0. And max and mean value will determine by the critical point at f prime equals 0. So from the f prime, you get the f increase, f decrease. You get the concavity also using the f double prime. Okay. It can be concavity upwards, downwards. This means, and if this is equal 0, meaning it might be the inflection point. It should be the inflection point. Meaning inflection point is if upwards change to downwards or downwards change to upwards. And we learn also here the indeterminate form. we call the Lopita Rule. The idea is to find, so maybe you have like this, and so on and so forth. There's a lot of indeterminate form, but the idea is to change all of this, become 0 over 0 or infinite over infinite. Then you can use the L'Hopital rule. The next one is the basically the whole thing here is used for the curve sketching. So curve sketching is combination from the basic definitions you get from the functions, domain, range, asymptote from the limit, and using f prime, f double prime, you get the curve sketching. And the last part is the optimization. It's the max and min problem. We need to find the constraint equation and find the optimization and find the f prime equals 0. And some notes, okay. I think to find the models of the functions, if we don't really know the behavior of the functions, okay, then just use the model as given in the questions, okay. If we are not really sure what's the behavior, if you want to simplify the models, okay, and then check the f prime, and then we get the critical point, and use the critical point to optimize, to maximize or to minimize, okay. Okay, I will start with some question from the midterm. Let me check the question first. I think number one is pretty similar from what we have done before in the quiz and also some samples. Number two, basically just put in the limit. Okay, its limit is going to 0, so this 0, 0. This is 1. This is 0 over 1, so it's just 0. And then equation of tangent line. Basically, you have this this function, and what you need to do is just derive both sides. Look for dy dx. I think because it's already mentioned that it's on this 3 and 1, x equal 3 and y equal 1. What you need to do is derive and then put the number and then just calculate. And I think directly you will get the answer for the dy dx. And you can check the tangent line based on this equation. Okay. And I think number 4, I think your TA already gave solutions, right? Number 4 is y double prime or not? Okay. Basically, you find the y double prime, a cos x minus b sine x, and then y double prime is negative a sine x minus b cos x, and then put all these informations to the equations and grouping signs, grouping sine x and cos x. Because there is no cos x in the right side, then all the cos x become 0, and all the sine x became the constant, and you will get a, b from substitution and eliminations. Okay. I think this already done before, sine tangent inverse. And how about this one? So every time you have like this functions here, okay? Every time you have any function with power, and maybe it's under the functions, if you want to make step by step without mistake or minimize your mistake, okay, let your functions become just y here. Okay? And take ln both sides. Okay. So you want to take ln because you want to move the power to the front. Okay. So move the power to the front. So if I have ln in 5 here, so I will have sine x ln 5. Okay. So this is from, and we move to the front. Okay. So from here, we can differentiate implicitly. So ln y become 1 over y dy dx. And sine x is just cos x. ln 5 is a constant. Then dy dx is, this y is 5 sine x, right? Okay. Then you get the answer. I think the number A. And this type of questions, okay, it's always principally the same. Okay, principally the same. So if I make more complicated, like maybe I change 5 to another functions, then maybe you will have some product rule or maybe some quotient rule, depends on the functions. But the idea is you make it with the ln first to move the power to the front, and then differentiate both sides. Okay. And then this is also similar. This is also similar. I think you can also check it if you want. Find linearizations. You just put in all x and a to this formula. That's it. And then this is we already done before. If we have f prime, so critical point is here, here, here. We have 4. Okay. So at 3, 5, 8, 10 is our critical point. At the positive region, f is increasing. At the negative region, f decreasing. We have done before. I think you should be okay. But remember, okay, remember to read the functions, okay, whether it's f prime, f double prime, or just f. Okay. Remember that. Not always f prime, so it may change. And then does there exist a functions blah 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 that f0 is -1, f2 is 4, and then f prime is always less or equal to for all x. Already we write mean value theorem, so use the mean value theorem. So first we need to check the number c. Is there numbers? Is there any c in between a b? And then let AB is starting from 0 to, so FB will be 4 minus 1 is 2, so 5 over 2. Because F prime, the maximum F prime is 2, and this is greater than 2, so there is no C satisfied. Okay. And then I think the functions here should be not too complicated, right? But probably if I want to write in the next exam, maybe it will be a little bit complicated, but it should be doable. It should be doable with certain amount of time. Okay? But the idea is find increasing, decreasing, max, min, is the basically using f prime. Concavity and inflection point is f double prime. So you need to find these both and then check the it's greater 0 or less 0. Okay, and then you can get increasing, decreasing to concavity and inflection point. And this is okay. Number 12. Any idea for number 12? This is actually quite interesting. It's basically the same principle with number 11. Fx is 8x over ln x. The question is just simple. Find intervals when f is increasing or decreasing if they have both. And also find the max and min if the value exists. So first look at the functions here. Okay. If you are not really careful solving the number 12, maybe you can write first solving the f prime, okay, because you want to find the increasing, decreasing, and max and min, right? So first solving the f prime. So find the f prime. So because we have a fractions, we are using the quotient rule. So quotient rule, so ln x squared, so 8 ln x minus 8x over x, right? So you get 8 ln x minus 1 over an ln x squared. Okay, you get this, and then maybe you're attempting to use the conditions 0 to look for the x, the critical point. So you want to find the critical point because it's also asking the max and min, right? So x will be what? Ln x is 1, so ln is. Remember, ln is log e, right? So this should be e, right? So x is e. If you're not careful, you'll find this is e. And check the e is around 2 point something. So maybe you can check 3, check 0. Or maybe check 1, because 0 is not defined, right? And you check e, and what will happen? So ln this will be negative. This will be negative. If ln 2 is around ln 3, positive, right? Positive, yeah, positive. Okay, then what will happen? You write, maybe you write this is minimum at x e, but the increasing or decreasing, because essentially you are ignoring the fact that this ln x is limiting the functions. Actually, this is having some restriction on domain, right? So you need to think the domain first. Okay, so ln x cannot be 0, right? So x cannot be 1, but x should be greater than 0, right? So actually, you need to include in this point is 1 and 0. And it should be open hole. And it should be negative. So you're decreasing at 0, 1. epsilon E and E infinity. Decrease, increase. Okay. Okay. So don't forget the domain. Okay. Another one is number 13. 1 plus blah 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 here. At which points on the curve does the tangent line have the largest slope? Okay. So it's quite tricky, but if you can understand, it means you need to find the y double prime. It's actually find the y double prime. You can think like finding optimization, okay? But the idea for optimizations, the functions need or the models need to be the tangent line. Okay, let's write the tangent line. The tangent. The tangent means the first derivative. So the first derivative is okay, and let's say this is equal t. Okay, because we want to find the largest, meaning the maximum value, right? So we need to maximize this y prime. So to maximize, we need to find another derivative. Okay, so meaning it's actually we derive twice. We derive twice. So if you want to make this is as our optimizations, you can make the model t or any symbols to think that okay, because optimizations you need to find the f prime to distinguish between what you have learned in y prime and y double prime. Then maybe we can have t. Okay, so we need to find t prime equals 0 to maximize our value. So let's look for t prime, which is the y double prime. So it becomes 240x minus 60x3 and equals 0. And you will get eventually this is 60x 4x squared minus, oh my god, 4 minus x squared. So x is plus minus 2. Check the plus minus 2. I think the largest slope will be around 240. So the answer is 240. Newton's method. Basically, these questions you need to use the calculator to find. But I promise you, there is no need for calculator. All the numbers should be easy to compute. So finding the Newton's method, fx is this. Find the f prime x, and use the x1, x0 minus fx, x0, x0. So you just put all the x0 based on the interval. This interval is 1, 2. Just start from 1 if you don't have any idea what kind of function. Start from 1, do some iterations, and you will have some 6 decimal places after you get x4 or x5. Okay, number 15 and 16. I think 15 we already did similar, but this 15 is without top. So the surface area is only pi r squared. And you can maximize these functions. Minimize, find s prime is 0. And this is, I think number 16 is interesting. You have a cone, okay? You have a volume of cone. I gave this volume here. So a cone is emptying water at rate 4 centimeter cubic per hour. The base radius, the base is here, the radius is 20, and the height is 10. And basically, the idea is, so if you have a cone and you have a water, you have a water here in with R and H as the volume of water, the blue one here. So this is water. So it will be emptying. So the water will come out. So the H will be, and R will be changed. Okay. R and H will be changed. Okay. So the questions, at what rate is the depth of the water in the funnel changing when the depth of water is 3 cm? So basically it's asking what is dH over dt, the depth, right? The height of the water. And to find dH over dt, of course, you need to find the relations, okay? So the important thing in related rate is finding the questions first. What is the question about? Okay. So because the question is asking the depth of the water, which means if this is the water here, the depth of the water is h, the rate of change is dH over dt, okay? And you have RH, and you have a triangle. One idea to relate RH and the whole triangle here is using the triangle property. So this is one way. So you have R is 2H, and the other is volume. We have volume is 1 over 3 pi R squared H, right? Because we have R is 2H, let's move this R. So all the terms will be H. Then we have volume is 4H squared, and it's become Q. Okay. Then, because we have the emptying water, we have the rate. Okay. So this 4 is the V over dt, the total volume. Okay, the total volume. So we differentiate with dt, we get dv dt, and then multiply with dH over dt. And this is what we are looking for. H, we get H from here. H is 3. So H is 3, dv dt is 4. And we can compute, okay? We can compute, and you can compute also. There, I give 2 bonus questions here. The first one is you have a function, this function here, 1 over x squared plus 1. But you need to understand the question first. It's a little bit complicated. I give these 2 as a bonus because actually number 1 is the most difficult problem if you don't understand what it means. Number 2 bonus, actually it's not that difficult, but it's quite long story, right? So the function is 1 over x squared plus 1. It's form a tangent line L by picking 2 points P and Q from the functions. You may visualize with graph, if not also fine, but this tangent line L is actually the line from P and Q. Okay, so we can, or let me go to details because I think we run out of time. Okay, let me go from to here. Okay, so the idea is we need to show, okay, if the absolute value of m is less or equal this value. Okay, so m is slope of L, and L is our line from P and Q. Okay. The first we can let picking any points. Okay. So maybe A and B or any symbols you want, and you have these two. And we need to define from these two what definitions or what formula that we can relate to this P and Q. Remember that if this is your tangent line, okay, this tangent, okay, or gradient, f over x, right? Fb minus fa over b minus a. Or you can say this is the average rate of change. So if it is equal tangent line, then we can use the mean value theorem when this is f prime c. So f prime c, we get the slope of L. So y prime is minus 2x over x squared plus 1 squared. Okay, this is first equations. And we are using this to equaling the rate of change. Okay, so let's say we have C here. Okay, and by definition given by the questions, let's say we have C. We have number C on interval AB. There is C on AB, and now the y prime is our slope, our m. Okay, and we need to show this is less or equal this value. Okay, so we need to use y prime, okay, as our model to find the number C. Okay, so basically we can also think this as optimizations. Okay, we can think this as optimizations. So this is actually similar to finding largest slope. So we need to differentiate twice. Then that's the model. So we need to find the slope of the y prime, okay, and find the number C. So we are differentiating this y prime. We get this, and solving this become this, and we are solving y double prime is this equation. We get our x is plus minus 1 over square root of 3. Okay? And we can check the extreme value for both of the minus and positive, both resulting this value. And based on what we have done in mean value theorem in the previous one, it will be proving that our slope will be at most will be, okay, because this, if you put absolute value, this will be the absolute maximum that the functions can get, right? This 3 square root of 3 over 8 is the absolute max value. So this m will never going above this value. So it's proven that this m should, at least the maximum should be this. Cannot be further than 3 square root of 3 over 8. So it's proven that this is less than. And the second questions, okay, so this is Luke, this is Yoda, and this is the X-Wing. So at the initial point, there are 300 meters in between the Luke and Yoda, right? And you know from the information from the questions, you are giving the 20, the rate of change of y. Okay. Then the questions. Okay. So you need to be able to find the questions from the related rates. Okay. So d theta dt when y is 400. Okay. So any related rate problem, okay, if they asking some rate of change when blah 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 blah, okay, just ignore this for the time being. Just ignore this, okay, and find the variables first. Okay, one way, because you want to find the theta, you need to consider what trigonometry you want to use. Okay, so I have tangent equal y over 300 because 300 is a fixed point. It's not changing, right? If, okay, for example, if the question having change in x and y is constant, then I think it's better to use cotangent. It's helpful for you because if you derive, if you just have this y, then the derivative of y over 300 is just 1 over 300 dy dt. Easy, right? But if you have the constant, maybe 300 over something here, then you will have, it will become minus a constant and then y squared, right? Maybe you will have mistake in calculations, maybe. But to avoid that mistake, please choose any trigonometric functions that easy to derive and easy to find. Okay, that's also my suggestions. So first, you can directly derive this tangent and put all the information, and you will get the d theta over dt is 3 over 125. Okay, and don't forget that when you need to find the theta, you don't really need to find which angle the theta is. Okay, what you need to find is just the ratio. Okay, to find the sine, cos, and then secant. Another way, okay, this is one way. Another way, instead of tangent, because it's asking theta, we can use the tangent inverse if you want. Okay, if you want. This is also a direct approach. So theta, you derive become d theta dt, and tangent inverse is 1 plus x squared, right? The x squared is the inside functions, and based on chain rule, you can multiply with the inside functions derivative and plug in the y squared, and this will be 25 over 9, and it's also same 3 over 125. Okay. Okay, I have one or two notes, especially for helping you to think and analyze the problem. Okay. Okay. Now I want to take some notes on limit. Okay, to give you some idea what we can do. If I have limit x approaching 0 of cos x minus 1 and then x squared. This is actually pretty much the noticeable limit. But if we use the Lopita rule, we can directly, and I think it will be helpful also if this is the case. So Lopita rule, because it's going to over 0 over 0, then it will be minus sine x over 2x. Still 0 over 0. Then one more time, Lopita rule. this will be minus cos x over 2, and resulting negative 1 over 2, right? Okay. So limit x, and for example, if you have limit as x approaching 0, okay, limit x approaching 0 cos x minus sin x with the power of 1 over tangent x. So if we put the 0 inside, it will be 1 over with the power of infinity, right? And this is actually our indeterminate form. Please do not answer 1, okay? Please do not answer 1. Please do not answer 1. This is indeterminate form. The idea, I tell you before, if we have any power here and we want to move this power to the front, we can use the ln. Okay, we can use the ln. If you want, there is at least 2 forms. Okay, you can have e with the power of ln and this whole function here, and you can do all the limit with e, or you can let this is the functions, let maybe y equal all of this, and then ln y. So you are calculating the ln, and at the end of the part, change the ln back to the e. That's you can do. 2 way for Lopita Rule. Okay. But I think doing the Lopita Rule, sometimes you will have really complex, messy. It's doable, but because it's limit, we can approach another way from this cos, sine, and 1 over tangent. Let me start with the limit x approaching 0, sine x over x is 1. Okay. And based on the trigonometry property, if you have tangent, this is actually the same as sine x over x. Right? So as x approaching 0, sine x, based on limit value, is actually similar to tangent x. Okay. And it's actually x, right? If sine x over x is 1, then sine x is x in limit as x near 0. Okay. And let's take a look at this, the minus half. Okay. I can write the cos x is actually, or let me write cos minus 1 is minus x squared over 2 as x approaching 0 in limit. Okay, in limit. And cos x is one over x near 0. Okay. So we can also change the limit, and this is true and doable in most of trigonometric limit. So we can change cos x become 1 minus x squared over 2, and tangent x becomes sine x. Sorry. And tangent become 1 over x. And these terms is more doable, easy to find the limit using, if you want to use L'Hopital, it's also shorter than using this directly to L'Hopital. So you can also do this. If you think it's too messy and complicated, then another way is you can, because it's limit, you can use all the limit trigonometry identity, sine x over x, there is 1 minus cos x, and others. Okay, and you can change here, and this becomes easier to differentiate. You can see like here, 1 over x ln, and do L'Hopital rule. So 1 minus x minus 1. And we get the answer directly. It's e to negative 1. But I've tried before using L'Hopital directly from this one. It's actually doable. You can also do that. Okay, but another way is just you can also transform the functions into another functions that easy to be L'Hopital. Okay, another way or another example. If I have limit as x approaching 0, this is ln cos ax, and this is ln cos bx, and a, b is constant, and what is the limit? What is the value? So it's ln1 over ln1 if you put 0. So it's 0 over 0 situations. I think we can directly going to L'Hopital. So this will be cos ax, and then multiply with the minus sign minus a sine x, and this will be cos bx minus b sine bx. The negative sign is canceling. So limit x to 0 the best way to look at this is you may use another L'Hopital if you see another 0 over 0. But my idea, you can also use the identity. So let me write this A going outside because it's constant, and limit, put limit here, and B put limit here, and it will be sine over AX and this also limit, and 1 over cos X. This also sine BX and limit X and this is 1 over cos BX. Okay. Now, let's multiply this with AX and AX. Okay. And BX also the same. Resulting, this part will be 1. This also 1. So I will have A, B, and this also 1. This also 1, right? So I will have A, B, limit X to the 0, limit X approaching 0, only AX and BX, right? And use L'Hopital. So A over B is L'Hopital rule. AX over BX become A over B. And this will be A squared B squared. So you can combine, limit identity sine X over X with the L'Hopital rule also to give you more faster way to solve. So, okay, I will talk a little bit what kind of midterm we will have. Okay, so the midterm notes. So we will have concept. So you need to at least idea for basic definition, limit, derivative, and application functions. So the concept, I will give you a statement, and you need to just choose whether the statement is true or false, and provide short with short explanations. You can start to look at your, if you want to look at the textbook, especially the review parts in your textbook, it will have true-false concept. I think it can help you to practice, okay, the concept. And another questions will be to analyze, okay, to analyze. So for the analyze, you will be given a questions, and I will provide A, B, C, D, and choose the right answers. And also you need to provide short or necessary steps. Usually when you derive like some functions, usually you take like long steps, right? But you can just take essential steps to show. You don't really need to write all if you want. Okay, just take necessary steps and choose one. Okay, choose one answer. And because it's mostly analyzed, sometimes the questions not having specific functions. Maybe the function is just given like fx, but it will be given property like maybe f prime x is always positive, or maybe you will be given f at some point is blah blah blah, f some points is blah blah blah, and you will be asking in some questions. Maybe you can relate to mean value theorem, maybe intermediate value theorem, or maybe relate to concavity or first derivative. It can be, or it can be combinations. Okay, so this will be the second type of the quiz question, and the third type will be just mostly problem solving. So mostly the problem solving will be about related rates and optimization. Roughly, the total midterm will be around 16 to 18 questions. I haven't decided yet how many, but I already make the questions on the weekend. But it's not fixed yet, so it's still around 16 to 18. So around 6 question, maybe 6 to 7 is true or false. Problem solving maybe 2 until 3. And this will be 7, at least 7, or 6 to 8. Okay, so yeah, the question is, some of the question is really different from last 2 years midterm and from your previous quizzes. It will be slightly different, and some is really different. Okay? What do I mean by different? Sometimes in the questions you will be asked like find blah 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 from this. It's direct questions, right? But in my questions, it's mostly analyzing functions, analyzing in which x values, blah blah blah. So it is not like usually you write and maybe you take a long time to write, right? It's not like that. It's more like you need to think carefully, and maybe you need to think out of the box to solve, because it's not about maybe you need to write long answers, short answers. It's not that. Okay? It's more analyzing. Okay? My advice, if you want to look for exercise beside your textbook, check other university exam if you want. Okay? Check. My suggestions if not the NTU, or maybe Chaotong. You can check their exam. That's example for how the questions all about, like how to analyze. So I think they have the questions is not difficult, but you need to be smart to answer. Like it's not really complicated, but if you point out uh, the right steps, then it's really short, really short. But if you cannot find that, then it's impossible to answer. It's impossible to answer. So the questions is not like, usually you need to have write long answers, and okay, it's complicated. It's not like that. It's more a simple way, but you need to think out of the box. Okay. And it's also really different from the last 2 years midterm, but the essential is the same. The essential is the same, but how to analyze is different. Okay. I want to try this kind of questions for you. Okay, if you can solve it by analyzing the questions. Okay. Okay. Any questions so far? Any questions? Maybe let me give you the QR code for those of you who haven't scanned. Okay. And later I will upload all the notes necessary and the last 2 years midterm for you to read, and maybe if you have idea and if you have any questions, if you want to email me, email me. Okay. Okay. I hope let's see the result of the midterm. Okay. I hope you can do it. Okay. Um, yeah. I think my suggestion is look for another sources for your exercise. Okay.
Will there be the correct answers for last year's midterm? You will upload.
Yes. Yes.
Okay.
Yeah. Yeah. You need to change first. Yeah. You can go. If not, then go to computer center. Yeah, computer center. I think they will have. Okay. Go to computer center. Yeah, computer center. I think. Yeah. What's good? Yeah. Yeah. I will upload. Upload. Yeah, I will upload.